Alright, so this is question 3.9, easy stereochemistry, and we're going to be doing parts A, B, and C. And for it, we're going to get a compound, and we're going to have to figure out whether it is E or Z. To do this, we're going to keep referring back to this hoop here. In order to decide E or Z stereochemistry, we have to look at the comparison point, or the first point of difference, and see what atoms are attached to it. So these are some of the atoms right here, and the ones with the higher atomic number are going to get higher priority, and you can kind of see that here. So we're going to start with part A first, and part A is this compound right here, and the first thing that we always do is we split the compound down the middle between the double bond. Alright, so now that we've done that, we can look and see our two different sides. So we're going to be comparing the left side, and then we're going to be comparing the right side. So on the left side we can start, and remember we start from that first comparison point, and it's the first point of difference. So on this, the bottom part right here is written kind of, it's not as clear here as it could be, so you're more than welcome to rewrite that if you would like. Here we have a C, a carbon, and it's connected to 3 hydrogen. And here we have a carbon, and it's connected to the 2 hydrogen, and this carbon over here. We do not consider this H3 because it is past the first point of difference. It is not directly connected to the first point of difference, so we're going to disregard it. So when we first start doing that, we're going to look and see there's 3 H's here that are connected to the C, and then there's 2 H's and a C. And sometimes it's really helpful to write it down off to the side, so we'll go ahead and do that. Alright, so now that we've got the left side done, we can look at the right side. And the right side has this carbon, which has two hydrogens and an oxygen attached to it, and then we have 1 chlorine down here at the bottom. Now the first point of difference is the carbon and the chlorine, and I'm not even going to bother rewriting the chlorine because that's obvious. And at the top I'm just going to do the carbon, but it does have the H2 and the O attached to it as well. So alright, so now we can see the 2 separate sides, the left and the right side, and that's when we begin to look at our options. So on this side we have 3 H's, and on the bottom we have 2 H's and a carbon, or 2 hydrogen and a carbon I should say. So we're going to look to see, back at this pink hoop, to see which has more priority over the other. So in the top we have 3 H's, which is here. And on the bottom we have 2 H's and a C, and we see that the C outranks the H. So we're going to go ahead and mark the bottom, because the bottom is going to have the priority. Alright, and now we can look at the right side, and we can see that the chlorine outweighs this carbon that we have right here. So the chlorine's going to outweigh the carbon, or outrank I should say. So we can mark that as well. Alright, and now we can see that both marked parts here, or the ones with the most priority, are both on the bottom. So when they're both on the bottom, or they're both on the top, but in this case it's the bottom, it's going to have the stereochemistry of Z. So that's going to be our answer, and we can put it down here. Alright, there we go, and that's part A. Alright, so now that we have part A out of the way, we can go ahead and start looking at part B. And as you can see on part B, we already have the line separating it down the middle of that double bond between the 2 carbons. And we can start looking at the left and right sides. So with the left, the first point of difference is going to be this chlorine and the oxygen, Now the oxygen does have the 3 hydrogen attached to it, but since it's the first point of difference, I'm not even going to write the Cl again, or the chlorine again, just because it's the only thing there. And then the oxygen I am going to go ahead and put in, just so I can kind of remind myself to ignore the carbon that's further on down the line. Because remember, we only look at the stuff that's directly connected to our first point of difference. So it's going to be our oxygen here. Alright, and now that we have that, we can look at the other side. Now this side gets a little bit more intense. The CH2 and the CH2 are the same here, but then our first point of difference is going to come with this carbon. So we have 3 hydrogen attached to this carbon, and on this carbon we have 2 hydrogen and another carbon. So we can go ahead and write that in. Alright, so now that we have that written down, we can look and see which one has higher priority overall. So you can go ahead and reference the pink hoop again. And we see that this chlorine here is going to outrank the oxygen, and I mean oxygen does have the hydrogen attached to it, but the chlorine is just going to outweigh the oxygen. So we can go ahead and put a line under the chlorine. And we can look and we see on this side there's 3 hydrogen and there's 2 hydrogen and a carbon. And that carbon again is going to outweigh the hydrogen, so we can put a line under this bottom compound here. And there we go. We can see that the ones with priority are on opposite sides, the top and the bottom, and that means that it's going to be E, stereochemistry. So we can go ahead and write that in. And there we go. Alright, now we can move on to part C. So here's part C, and again it's split down the middle for us, so we can look at the left and right sides. So on the left side we just have this hydrogen and the carbon on the bottom. That's our first point of difference, and I mean the hydrogen is already there, so we don't have to rewrite it, but we can go ahead and rewrite the carbon if we would like. Alright, and we can go ahead and look at the right side now as well. Now the right side is a little bit trickier because you see that this has an N here, a nitrogen, and this carbon has a nitrogen and 2 hydrogen. So your first idea would be go to the bottom here, but you have to remember that this carbon and this nitrogen actually have a triple bond between them. And when there's a multiple bond like that, whether it be a double or a triple, the atom that's attached counts for that many times. So in this time it would actually be 3 nitrogen. So I'll go ahead and write that in. Alright, so now that we've done that, we can go ahead and look at it, and so this carbon is going to outweigh the hydrogen that's up here, so we can go ahead and put a line under that. Alright, and then we can start looking at the right side now, and referring back to this pink hoop, we can see that the 3 nitrogens are going to outweigh the 2 nitrogen, or the 1 nitrogen and the 2 hydrogen, I should say. So we can go ahead and put a line under that one. And there we can see that it is on opposite sides again, so that means it's going to be easy stereochemistry. Alright, there we go. So we have part A, part B and part C. Z, E, and E stereochemistry are the answers.